So first of all, a quick table of contents. So a quick introduction about the Equalizer, Equalizer Academy, and then we will make a quick recap of what we learned so far. And today we will check in more details what are interfaces and application binary interfaces. So we already looked at interfaces very briefly in one of the previous lectures. However, today we are going in a bit more detail. And also later on in this lecture, you will have a hands-on workshop to see how to implement things, how to interact with smart contracts, and how to deploy them, and what different parts of smart contract perform. Okay, very briefly, Equalizer, as some of you already know, is the first dedicated platform that equalizes the decentralized markets. It offers flash loan as a service. The team is also working on other products that will be released soon. It is a flash loan platform. We also provide an Equalizer bridge to transfer EQZ tokens from Ethereum to Binance Smart Chain. And of course, this beautiful and extremely useful Equalizer Academy. In this academy, we are covering a wide range of topics from implementation, business capabilities, different scenarios, what is possible to do with the flash loan, what are the flash loans, why flash loans are possible, and similar. We welcome everyone also to our Equalizer Discord channel, where you can find several channels grouped by different topics. You can exchange ideas, ask questions, make proposals for the academy, and others. Of course, you can introduce yourself, find new partners, and interact, teach others, and also learn from others. So it's a great way to interact with each other. Okay, so what we learned so far in the previous lecture. So in the last lecture, we take a look of compared loans, flash loans, and we explain what are collaterals. We also explain why collaterals are not required for flash loans. And then we also take a closer look at flash loan use cases, at arbitrage, collateral swap, liquidation, and self-liquidation. We went into more into details what these business operations are. We presented some useful scenarios for our arbitrage, for example, and also built a good foundation where you can start from. So once you have a business use case here, then you can use other knowledge that we share here with you so that you can build different components for your use case and of course make it work. What we'll learn today. So today we're deep diving into Solidity, and we will basically start with interfaces. Interfaces are, as we'll see, extremely useful. They are applications we use interfaces all the time. And interfaces really allow us to abstract away, or separate the way we interact with the service and the backend service itself. We will also look at the smart contracts application binary interfaces, what they do, how they look like, and what they actually mean. And then, of course, you will have this hands-on workshop. If you will have any feedback, questions, remarks, feel free to ask anytime. Okay, so interfaces. By definition, interfaces are methods or functions that form the object. So methods or functions that form the object's interfaces with the outside world. And the simplest example is a button in front of your TV. That's basically an interface between you and the electric wiring on the other side. And as you may know, every TV or remote has an on-off button, and this is what an interface actually is, and this is how you interact with the TV. However, it really doesn't matter what's the wiring behind it. And the same goes for software. Software interfaces are definitions that tell you how to interact with services, but you don't need to know anything about how those services are implemented. If we take another example like a bicycle, what would be by interfaces of a bike. For example, one could be change gear, speed up, or apply brakes. But how this is achieved depends on the type of bicycle you use, the type of gears it has, type of brakes it has, but you really don't need to know anything about those details. So you only need to know that you can interact with your bicycle. So, for example, so that you change gears, speed up, and apply brakes. And this is the simplest example and presentation of what interfaces are. And the important thing to keep in mind is that interfaces define how you interact with the service. However, they allow us to have any implementation in the backend we want. And now this will be extremely important when we start talking about smart contracts and interacting with smart contracts of different kinds. Before we go to smart contracts, I would also like to present application programming interfaces, or APIs, because APIs are the interfaces you will meet most often, and APIs are something we basically interact on a daily basis. APIs can be REST APIs. They can be JSON RPC APIs. Or it can be, you can interact with them via WebSocket. So the type of APIs is of course defined by the service itself, and these services also define how you interact with the API. So for those who try to interact with, for example, blockchain nodes via JSON RPC, or WebSocket, or via Infura, they define APIs, and you use these APIs to interact with the service. And you don't need to know anything about how the blockchain client is implemented. For example, you have a Go Ethereum client, you have a Rust client, you have a client in C++ and Python. And all of these clients are of course implemented differently, but you always interact with them in the same way. So here's a very brief presentation. So we have Alice. Alice always interacts with the APIs that follow a particular standard. And if these APIs follow the same standard, Alice will be able to interact with different kinds of services, A, B, and C. It doesn't matter how these are implemented, what programming languages are used, and so on. Now let's go to smart contracts. We already know that for all the tokens and NFTs and all the other, say, popular decentralized apps, we have standards which are usually come either as an RFC, Ethereum request for comments, ERC, or Ethereum improvement proposal. And here, for example, we can see we have several token standards like ERC20, 721, and others. And all these standards, if you take a look, you see these standards define a standard interface for tokens, right? Different tokens. Now, no matter with what token you interact, no matter what token you transfer, your wallet will always perform the same action. And this is possible because we have these tokens follow the standards that define the interfaces. So you know how to interact with, but you don't need to know anything about the implementation. Same goes for the flash loans. There's a 3,156 Ethereum improvement proposal that defines standard interfaces for flash loans, so for both borrowing and returning. And this enables, so for every service provider that follows this standard, you can interface with your own implementation. And also at Equalizer, we do follow the standard, so it's very easy and seamless to transit from different protocols to Equalizer and vice versa. Following these standards, it has advantages for both users and service providers. For users, it means that if you develop business logic that is interacting with one standard, you can simply transit to another service provider following the same standard. And for service provider, it's also beneficial to follow standard and implement standard interfaces, because it's much easier for other users to transit and use their services. So the time to market and effort to implement the changes is much lower. Let's take a look at the example of an interface in Solidity. Interface definition is very simple. So it starts with interface. Name of the interface, it usually uses a capital I counter, and only defines the methods. So we see that I counter has two methods, count and increment. Count receives no argument, requires no argument, and returns an on-site integer, whereas increment doesn't require any argument and doesn't return anything. Now, the I counter then needs to be implemented, right? And here you will be able to see, if you check this example, how for example, this is implemented. However, you could create your own implementation of count and increment. So here we have methods, and if you would call these methods in this smart contract and your smart contract, it would basically require no change except for the address you're calling. ABI, or application binary interface, is used by a smart contract so that you, when develop a software that interacts with the smart contract, you can understand what are the methods, what are the method name. On the other side, it translates your calls into something that is understandable by the EVM. So here you will find in the Solidity specs, you will find all the details, but yeah, for those who are interested. But here we can take a look at how ABI looks like. So on one side, this is what you will usually see. So you will see what are the inputs, what are the input parameters, what are their names, what is their type, and this is to help you to interface with the smart contract. And also, but these inputs are then also used to transform your code, your software, into something that an EVM can understand. And of course, if you want to interface or interact with any smart contract, you need this, because without the ABI, you would need to decode. So as we saw in the previous lectures, that Solidity is a compiled language, and you take your smart contract code, you compile it, you get a series of bytes. And of course, with those bytes, you cannot understand them without the ABI. Let's start with the workshop. I will give access to Stefan, and we can continue.
Hello, everybody.
Yes, we can hear you. Feel free to introduce yourself.
So my name is Adi. I'm a developer. I started to work on the Ethereum in 2017, and now I have about 5 years of experience in it. I was kind of biased that year with Ethereum because, well, everything was on a bull market at that moment. So, yeah, why not? And yeah, the truth is, it gives you, it is a new way of seeing or solving problems where the power is given to people rather than institutions or central authorities. For this workshop, I was thinking to show you some of the shortcuts that I'm using in order to, I don't know, do a trial and error on every piece of problems that I have, and it works very well with smart contracts and interacting with the blockchain itself as well. So to create smart contracts to test and deploy them on either chain you want, I use Remix. This is a very nice tool where you can write contracts, compile them, and eventually deploy them, and afterwards interact with them through their interface. They have also web interface based on the ABIs that they are creating on your smart contracts. To interact with the smart contracts in a more complex way, like doing some other computations or different other tasks, I'm using this website. It's called Replit, yeah, and it's very nice because actually you can create all sort of different language templates and then you can use them. For this academy and this workshop, I am using Node.js. The reason is very simple. I even created a template here. The reason is very simple. Best libraries to interact with Solidity and the blockchain are written in JavaScript. And as you well know, Node.js is just a backend JavaScript. Let's go from where Alan left off. Everything starts with the smart contracts, right, on the blockchain. What is I'm going to take a little bit of background here because I don't know exactly, or if you all have been in all classes, but basically a blockchain is a set of rules that are created by some people, and some other people, like big companies, are developed clients, like maybe you've heard of Parity or Geth Go Ethereum, for a client implemented in Golang language. They implement this set of rules, and what this set of rules says is if we all follow the same rule, then we should eventually reach a consensus. And when a consensus is met among multiple clients, a new block is created, and it all started from Bitcoin blockchain, where the main implementation there is on a single coin. It's Bitcoin itself. And the consensus basically is stating at any point what is the balance of each address of Bitcoin. Now, what Vitalik thought some years ago now is what if among this consensus we can also implement a virtual machine, which is called Ethereum virtual machine, and basically make those clients that run in consensus to also run code. And in 2015, Ethereum was launched on this idea, and it grew to this moment, and you know what it is now. In order to interact with the Ethereum virtual machine, which is basically the computer inside this blockchain, there are multiple ways. You need to eventually deploy some smart contracts at a given address. It can be pre-computed, but maybe we will do it in a different workshop, this one. Or it can be random, but this is like a deterministic random. I mean, it matters on one hand what type of what lines you write in your contract. On the other hand, it matters what account and how many transactions you have sent from that account to pre-compute that address. So it's not random address, it's based on some deterministic. I mean, every time you run the same algorithm with the same context, it gives you the same address. So what is a contract? Is a piece of code that stays at an address, and you can eventually access it through the ABIs that Alan was talking about a little bit earlier. In the blockchain, there is a deployed bytecode, and to get to the bytecode, there are multiple ways. One of them is writing code in Solidity and compile it. There are other languages that compiles contracts and can be deployed, like Viper, for instance, or LLL is another one. So we will stick to Solidity. Solidity is, from my point of view, maybe the most mature language to write smart contracts. It was written by Vitalik as well, so it's now is worldwide adopted, and it's continuously developing new versions appears pretty often. I say it's, as you can see here, the version is 0.8, so we don't have like a version 1. It's still in some kind of beta version. Let's go into more funny stuff to do. So I was telling you that I use this remix to write pieces of code and compile them and deploy them. I will create now a new file. Let's say this one. I will use some lines from other files. Okay, so those comments are to tell the compiler now is like a standard to define for every file which type of license you have. The next line I wrote here is to tell the tool you use what version of the compile to use. In this case is the latest version of 0.8. Okay, and then the contract itself. Let's create, I'm going to show you and demo a way to a simple smart contract that we can deploy on Ringkebby blockchain testnet and interact with it. So I'm going to write some contract greeter from accuser, let's say. Here in the contract, I'll even declare a variable, let's say a string to greet, and let's say we want to set it from the constructor and show it, and eventually create a setter to modify the variable inside of it. Okay. In this way, basically, when I deploy the contract, the constructor is a function like any other functions in defined in the smart contract that is only called once, and this is happening upon deployment. Once the contract is deployed, and it can be found that address, this function that is the constructor cannot be called anymore. Okay, so I'm going to, yeah, I have this constructor, and I'm going to create another function that reset the grid to something else. Okay, so set with another grid. I'm going to state that this function is public, so it can be called by anyone, and I'm going to set the grid with another grid. Now, because I have set this variable to public, Solidity or the compiler automatically creates me a method that is called grid to see this variable directly without defining any other getter. But so I'm going to show you that as well. But I am also will define another function. Let's call it show me the grid, right? Without any parameter. I'm going to make it external. I'm going to state that this is a view function and not something that changes the state of the smart contract. And I'm going to explain you just in a bit what is the difference. And I'm going to state whatever this function returns. In this case, it returns a string from memory. Okay, and we just return the grid. Now, I was telling you what is the difference between public and external. It's not much of it, or at least it is something. The difference is that an external function like this one cannot be called from inside the smart contract, but different other contracts or wallets. The public functions can be called from the smart contract itself as well. If I have a view defined on this function, it means that I cannot send a transaction to modify the state of this. So this function that is marked with view cannot change any variable defined at the beginning of the smart contract. Yeah, basically this is the difference. Those are some warnings, best practices by the team itself. So right now the contract compiled, so we can go to this tab and we can use injected Web3. It automatically uses my account because I connected the previous with this address. This is my account on Ringkebby. I have 32 Ether. It's free. You can get Ether from Ringkebby by using Ringkebby public faucets. So you can use them. and I want to deploy the smart contract, I need to say some string to grid. Hello from EQZ. I also have an options. Instead of deploying the smart contract, supposing that I previously deployed, I can load the smart contract with the ABI that by compiling already was created at some address, so I can call it directly. It's not the case. We want to deploy, so I push the deploy button. I don't know if you see the MetaMask confirmation. It shows on my computer. I am pushing. I signed it, and now the contract is deploying. We can see on Etherscan on Rinkeby blockchain explorer the status of the transaction. Rinkeby doesn't show because it might be delaying some blocks because of forks or some other stuffs. But on Remix, you can see that the transaction was deployed with index 20 inside the block. So the 20th transaction in this block. And in Remix here below, you can see that your deployed contract, and we have greeter from EQZ, the deployed at this address. And we have function grid, which I told you that Solidity automatically creates, even though I didn't define any function. But because I set this public to this variable, then it automatically create me a getter. So if I call it, it shows me the output, the decoded output, hello from equalizer, or here you can see it. Or you can push this show me the grid, which returns the same grid that I defined previously, and yeah, it's the same thing. Now I'm going to define another grid. I push the set grid, it will automatically pop me the MetaMask to sign a transaction, because this one changes the state of the smart contract. So transaction is actually broadcasted to the blockchain itself, whereas for view functions, you don't broadcast any transaction to the blockchain. You just make an RPC call to the node, to the API that Alan was talking about a little bit earlier, and the node returns the value without actually broadcast. So you don't consume ether on none of the blockchains if you are calling only view functions. So you consume ether to pay for the gas fee only when you set and modify the state of the blockchain. Now you see that the transaction was mined on Etherscan. This is a transaction again. Rinkeby is here. This is the deployment. This one was eventually parsed by Etherscan. This one, okay, this one was also parsed here. Nonetheless, the transaction was successful. So if I push now grid, it will change the string to what I have set previously here, right? The second grid from equalizer, and also this function show me the grid, because it basically returns the same variable. So this was a little bit of demonstration how to use Remix, how to write a smart contract, and interact basically through Remix interface to the smart contract itself. I'm going to read a little bit the chat. Okay, so now other new messages. Right, so I don't know how much time, but we will get through it by working and doing a smart contract and interacting with them for the flash loan. And we will continue the next lesson if we don't finish it today. For interacting with smart contracts, I was telling you that I'm using this website. I also created a template here, which will stay public. I mean, you can go and look at it and have the code whenever. I just posted it on this chat. What I have here, first thing first, is when you create this one, whenever you do a require in the index.js file here and push a run, this website will automatically create a package JSON file and downloads this library into node modules. As you can see here, it has already the dependency of ethers. What is ethers? Ethers is a JavaScript library that give you some interfaces, some easy ways to interact with smart contracts. We will get to it more deeper. I have a node URL. Whenever you do something, you need a client that is synchronized and connected to the network. Hopefully this client that Equalizer uses, and it is provided by the Equalizer sysadmins, is connected to the Ringkebby blockchain. We will check it. We will check this one as well. We have some other variables. It's the flash loan provider. I have taken it from the documentation from Equalizer Finance. It's for Ringkebby is the flash loan provider, this one. And yeah, it's this one. And then I have a private key, which I generated it with jancoleman.io, and I strongly recommend you this one. You can easily generate addresses based on different. So you put some words to automatically generate, and then you choose coin. I use it at Ethereum, and then based on that mnemonic, it generated. This is the mnemonic. It automatically generates a derived address. So I use the first one. It's this one, private key. I'm gonna check it one more time. No, it's not that one because I use the public key. So it's private key is this one. And then private key is this one. Okay, which eventually gives me this wallet address. And then it's the Equalizer token address that I also took it from the Equalizer documentation. The token Equalizer is the last one here. Right, okay. So let's go back. So I was telling you that let's first create a provider object that can throw calls to the RPC node and show some stuff. So let's define a variable Ethereum provider, right? Equal with new ethers providers.json RPC provider. It has some sort of autocomplete as well. And as an URL, we will provide the node URL that we have defined previously. And right, if we run it, we will see no error message, hopefully. Let it initialize itself. Okay, we have no error message. So if I'm looking to the Ethereum provider, it shows that it's connected to the network itself. And the network is Ringkebby with chain ID 4. So I'm okay. Now I know that I'm connected to the right chain. Okay, next thing we should want to do is to take, basically this is the workshop that we're trying to do, is to take flash loan of Equalizer token. And let's take the simple case first. We just take a flash loan and then we pay it back without doing anything. We will see later on what we need to do to make something with this flash loan as well. So first thing is we need to interact with this flash loan provider and take a flash loan provider. If we are looking into the into the documentation of Equalizer, we see that how do I borrow flash loan? Or maybe let's go to the GitHub in Equalizer Finance. You will see here the Equalizer smart contracts. And here in the flash loan provider, you can see that in order to take a flash loan, you need to call this method flash loan with parameter receiver, a token that you want to take a loan on, an amount of that token, and eventually some extra data that you want to embed here in this call. First thing is that we need to point this function flash loan to a receiver, but this receiver is not a normal address. It's a type of interface 3156 that Alan was telling you earlier. Therefore, in order to take a flash loan, we need to have an address which is a smart contract that implements this interface. So we are going to do it in Remix, this one. So we are going to create another file. I'll just take these 2 lines here, and flash loan receiver. We are going to call it. I'm going to look inside the smart contracts here, and in this file, I'm going to copy the interface of this one that I need to implement in order to execute the flash loan. So in Remix, I'm going to define here my interface, and then I'm going to write my contract flash loan receiver is a flash borrower. By doing this, I'm basically saying to my contract that every method which is defined in this interface needs to be implemented here. On the interface itself, you can see the definition of the method, but no code in it. So I'm going to take this function and put it here, and instead of ending it here, I'm just will open some curly brackets and just make a simple implementation for it. So in this case, let's go on the flow on the smart contracts on Equalizer on this provider and see what is it with that function. So we will call a flash loan function with these parameters that we just, then we see that the provider is doing some checks. Then on line 78, it initialized the vault that has this token that we have required, and then some other checks. Then it computes a fee for the amount I am asking. It computes a fee that I will need to pay later on. Then what it does on line 86, the provider basically lends you the money. So it's transferred to account to the receiver, which is my contract address that I will deploy, and the amount. And then we'll call this method. And this is why on flash loan relies on the receiver implement this flash borrower, because he hopes that this address, that is the receiver, has this method defined on flash loan. As you can see in this interface, the function is called the same. So the call will succeed. So the provider will call this function, and after the function is called, it will automatically try to transfer back from the receiver the amount that it gives previously, and the fee as well. So he hopes to take the amount plus fee back. In order to succeed in this flash loan, we will need to implement this method to actually first thing that it checks here is this callback success. This callback success function, it is a SHA 256 of this string. So I will take this one and define in my contract as well. So I will say callback success, defined it they do it there. And then on this on flash loan, the most important thing at the end of this callback, I just need to return the callback success to be successful from the provider point of view. Here, basically, in this space is what we will probably do next time. Code the logic to make an arbitrage between two exchanges. We will see how we will do it later. But before this, in order to be available, to be able to, we need to allow the provider the right to transfer back his funds. So in order to allow the provider to transfer back his funds, I'm gonna set an allowance on the ERC20 token. So maybe we'll go to Etherscan or ERC20 token standard interface. And I'm going to define this method as another interface that I will use. I don't need the entire code because I know this token is following that we are taking flash loan on. It's following the same interface. So I'm declaring an interface here, which is ERC20. And this interface has a method called approve that returns success. And here in our smart contract, we will do initialization of the ERC20 token smart contract. So I will just do a, let's put here interface. I will put here an ERC20 token of token. So I initialized the token to the interface, and I just call an allow. I will copy it from here. Approve, not allow. Approve. Whoever send me the funds below, and the value, I will call it amount plus fee. So I allow on this token to spend in my account. So I allow to this wallet to spend in my account amount plus fee here. And then I return callback success. Now, in order to be able, this smart contract that we will deploy it, will eventually need to have some to have enough tokens. So this amount plus fee, he will need to have it in his balance in order to succeed. Otherwise, this transfer will fail, and we will work on it and show it. Let's compile. Here, when you compile, hold on a second. Yeah, compile flash loan. Okay. All right, we need to external override. Okay. And there is some warnings, but in the end, eventually it worked. So right now I compiled my flash loan receiver. And what I have to do is to basically now deploy it. I'm going to deploy. I'll here when you want to deploy, you have an option to choose from the smart contract, from the contracts defined here. It is also, there are also shown the ERC20 and the borrower as well. So I'm going to choose the flash loan receiver and just deploy. Now it pops MetaMask transaction, which I signed, and now we will look on Etherscan. Probably it will be slower there than directly here. Okay, so the transaction hash is this one. This one is still pending here. From to hash input, right? And yeah, so you can see here my contract is right now deployed. My contract address, so the receiver, of course I don't have anything here, but I can verify and publish. Let's say select the single file, compiler version. We will look here, it's the latest version, basically. And we are going to copy the entire text here. MIT here, continue, Solidity code. We have optimization here, not robot. Right, and we have no constructor arguments, so you just publish it. Start over. We will do, for some reasons, it didn't get the same bytecode. Anyways, right now, in order to interact with this smart contract, we need to go and make a transaction to this smart contract here in the repo, and I'm going to define the receiver address, which we just created, as this one here. Now, in order to interact with it, we need to create an object to an ABI, and I'm going to create an ABI, and because I don't have it defined there, I'm going to make it by myself here. And this ABI is basically this function. Hold on to put it on a single line. So this is the ABI, and I'm going to define a contract. My contract is receiver contract equals new ethers.get contract at ABI and then is the address, receiver address, and then is the network, Ethereum provider. Right. It's not with new. It's await. It doesn't work with await. Let's try to execute a sync code here. Okay, so here I have my sync function. So here I can put await async. Right. I'm going to try to verify it again. To take the entire ABI from Etherscan. Right, 0.87 without optimization. So maybe this was the problem. Okay. Let's verify. Okay, so now if we are going to the smart contract, we can see the verified smart contract. and also the ABIs, which I will copy it to the clipboard, and I will define it here. The ABI is this one. Now should work just fine. Right. So the reason it didn't work as I wanted is because I was using in my previous test some other implementation of ethers, but this is the real documentation of ethers. So to attach, or this is to create to attach to an instance, I will need to basically create a factory and attach to the address or name of the contract that I have previously deployed. So I'm going to create a new contract here. So there's contract. Where the address is the receiver address. In my case, the ABI is the ABI, and the signer or provider is the, not this one, the Ethereum provider. And now here on the contract, I can call my function on flash loan, of course. Shit. Okay, so in order to see everything works, I eventually can return the one of the variables that are defined as view functions here, as I showed you, and I can, this one is made public. So by default, the Solidity will create me a function with callback success name. So I will try to log contract callback success. So it returns me this string, which is the some variables that it is defined in the state of this smart contract. Now the next thing to do is to basically call the function, this on flash loan, but this function is not called from this smart contract, but is called from the provider. So next we will need to initialize the provider as well and perform a flash loan on the provider with this receiver I have just created. Alan, do we still have time, or do we need to leave it on the next lesson.
I mean, you're in Element, up to you. We are 15 minutes over time, so we can continue next time. Or if you want, you can finish it now. Up to you.
I'll leave the code. I mean, I'll post it into the Discord, this URL as well.
Mm-hmm.
So maybe next time we will go onwards from this point.
Okay, perfect. Then we will share all the links and code with the audience. We will also put it in the GitHub, and we continue from here next time. Okay.
Cool.
Wonderful. Thank you very much, everyone, for joining. This was it for today. Feel free to provide feedback or ask questions in the Discord channel. Join us there. If you have any questions, let us know. We'll be happy to help. And we wish everyone a wonderful rest of the day.